This video is going to help us learn how to label and understand our periodic table. If you don't have a periodic table that looks exactly like this, they're all pretty much structured the same way. You can apply these labels to pretty much any periodic table. If you are in a class that has a periodic table like this, it will help you organize it a little bit better. But we want to be able to use the periodic table to quickly access information about each element on the table. And the periodic table is really a helpful thing. And we're going to put some labels on here to make sure that we can access that information as easily as possible. We're going to start with labeling the periods and groups on our periodic table. You can see the groups are labeled 1 through 18, and you can see them as they go across here. On our periodic table, the G stands for the group number, and we have these little spots for each number here. And if yours is not labeled, you can label them right on your periodic table. Sometimes they're labeled using Roman numerals instead. We're going to go ahead and just use regular numbers 1 through 18. Now, groups are vertical columns on the periodic table. This is group 1 with hydrogen, lithium, sodium, potassium, and so on. Group 2 would be right here, beryllium, magnesium, calcium, and so on. Then we have these transition metals in the middle that are groups 3 through 12. Then group 13, group 14, 15, 16, 17, and 18. Group 18, vertically here, starting with helium and neon and argon. Those are the noble gases. That's a special group that we want to make sure that we understand. So the groups are sometimes called families. They're vertical columns on our periodic table. Now we can label the periods. The periods are horizontal columns. So this would be period 1. There's only 2 elements in it, hydrogen and helium. Period 2, going left to right, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. And then going on down, period 3, period 4, 5, 6, and 7. That's how we're going to label our periodic table for the periods. So again, we can organize them and kind of see where they are based on their groups and on their periods. Now, we have some other things that we're going to look at here. We're going to look at the valence number, the oxidation number, and whether it's a metal, nonmetal, or metalloid. Valence number is next. The valence number is the number of electrons in the outer energy level, and it's the number of valence electrons that the element has. And what's cool about this is that all the elements in the group have the same number of valence electrons. It's one of the patterns on your periodic table. So group 1 actually has 1 valence electron, 1 electron in its outermost energy level. Group 2 would have 2 valence electrons. That's why we have the 2 right there. Now the middle, the transition metals, there's no pattern as far as how many valence electrons they have. So we're not going to put them in. That's going to vary from element to element, and you'll have to get some more specific teaching on those. But starting up with group 13, we know that boron and aluminum, they have 3 valence electrons. So all of these elements in this family have 3, and then we have 4, 5, 6, 7, and 8. Now, the helium is a little bit of an exception here as far as 8 valence electrons. It has 2 valence electrons. But other than that, everyone in the noble gases has an outer energy level that's already filled and 8 valence electrons. All right, oxidation numbers. Oxidation numbers are based on the valence number. It's the charge after it gains or loses electrons. So there's some patterns here also. Everybody in group 1 has an oxidation number of +1. They're most likely going to lose an electron, which would give them a +1 charge. Group 2, +2. Again, the elements in the middle, the transition metals, there's no pattern, so we're going to leave those without oxidation numbers on there. Then we have group 13, which had 3 valence electrons, has a charge of +3. Now, group 14 is a little bit different, has a plus or negative charge. That's what this says. A plus or minus of 4. That means it can gain 4 electrons or lose 4 electrons. Then heading the other direction, we have -3 for all of these, -2 for group 16. Fluorine's family is -1, and then the noble gases, because their outer energy level is already filled up, they have an oxidation number of 0. All right, last thing, we're going to color in and have you color in the metals, nonmetals, and metalloids. The metals are on the left side of the periodic table. So all these, and there's going to be a little staircase that goes in here for the metalloids. Anything left of that staircase, we would say that those are metals. Nonmetals, I'm sorry, we'll go to the metalloids first. Metalloids, they're here. These have properties of metals and nonmetals. And so this little staircase separates the metals from the nonmetals. Those are called metalloids. And then finally we have the nonmetals over on the right. And so these nonmetals are on the right side of the periodic table to the right of the staircase as we go through there. So you can have those colored as well, because it may ask you which of the following groups would be composed of all nonmetals, and you'd be looking over here at group 17 or 18 or something like that. So again, easy things to pull off your periodic table. I would color those in. I would make sure that you color them in lightly so that you can still read the atomic number and the atomic mass and the mass number and any other information that is given to you on the periodic table. So hopefully this was helpful. Hopefully you now have a periodic table that looks like this, something that you can use and get information off of easily and quickly, and that you can use it to help you understand the periodic table a little bit better.